So when we find distance between 2 points, you can use the distance formula. Has everybody here seen the distance formula at one point in time? Because it's very intimidating. And it's distance equals a long square root x1 minus x2 squared plus y1 minus y2 squared. Okay? So let's say we're finding the distance between -4 and -6 and 5, -1. So when you're using the distance formula and using your calculator, you can put it all in your calculator at one time, but you have to be careful with parentheses. So what I tell kids to do is to put the information in your calculator without the radical, and then you square root that answer, and it's a lot easier than putting it all in your calculator. I'm going to graph the points, -4, -6. If you're on the Rocket Book, there's some rulers behind you you can use. 5, -1 is right here. So I usually mark them so I know what I'm talking about. And -4, -6, okay? So when we draw our triangle, we get that it's on the left side is 5 blocks, on the top is 9, and we can use our Pythagorean theorem. And the only rule about the Pythagorean theorem that you have to remember is that the diagonal is always the C. You can't put him just anywhere, but the other two are A and B. It doesn't matter where you put them, okay? So we have 5 squared plus 9 squared equals C squared. 5 squared is 25. 9 squared is 81 equals C squared. That is 106. Does that look familiar? How do we undo a square? What undoes a square?
The root.
A square root, right? So you square root both sides, and you get that 10.30 equals C. If I have this picture and they're to say to you, what is the length of segment JL? Remember, segment has a line on it with no arrow. You can't find the length of a line. Why? Because it what? It's infinity. The length of every line is infinity, and so you can't. But you can find the length between J and L, right? What are you going to do with those two numbers? Add them together. So I think it's 1.10 is what the answer is to that. So that would be an easy one, okay? If they want the line of PR, if it's 5.8 miles to get from P to S, and from R to S is 3.7 miles, then how far is it from P to R? You would take 5.8 minus 3.7, which is 2.1. So this one right here would be 2.1. In this picture, what tells you that all those segments are equal?
Blue line.
The blue tick marks. Those tick marks tell you that they're all equal, okay? Now you can divide by 5, so you know all of these are going to be 3s. And we're going to introduce a word in geometry. It's congruent. Have you heard that word before?
Mm-hmm.
If things are congruent, they have the same measure. They're equal to each other, okay? If I have a picture of a shape like this, and I have 1 tick mark here and 2 tick marks here, what do I know?
That these two equal the same as these two.
Anybody who has the same tick marks are equal. So if I know that this side here is 4, then I know this side here is 4. And if I know this side here is 6, I know this side here is 6. I can make that conclusion, okay? Now, before I leave this problem, I want to talk about the fence post. You are building a fence in your backyard. Has anybody ever done that or helped do that? Oh, wow. Got 1.5 people who have built a fence. When you go to Home Depot to get the sections of fencing and the posts, do you get the same amount of each?
No.
What do you get? If I get 6 posts, how many sections do I need? If I get 6 posts, how many
4.
Uh-uh. 5. You always need one more fence post than you do fence sections. Think about it.
Oh.
I have my post. I have my section. I need another post at the end to hold it up, otherwise it's not going to do well with the first rainstorm, okay? And then I need another section and another post. So you always have one less section than posts. So in this problem, there's 6 letters, but there's only 5 sections. Do you understand that? Remember the fence post rule when you're doing that.